Now we got this complete topology, and we also saw some tuning of origin, but that's not the way it has to go. We need to do in sequence. First of all, we're going to focus on the attribute weight, because weight comes first before the origin. So let us go back to router 3 and remove those configurations that we did. So that we can start the weight lab. Show run section router BGP. I have already removed it. I don't think there's a route map. Show IP route map. Show route map. We do have a route map 2 to 1, something like that, but we are not using it anyway. So for my satisfaction, I would like to remove even that. All right, done. Show route map. No route maps. Even we wrote a prefix list, not necessary to remove it because we have not attached to anywhere. The route map which it was having is already removed. So the prefix list is not going to impact in any way.
It's map stack to a
route map or yeah, route map or interface or somewhere, unless and until you attach this, it's not going to be. It's simply configured. That's all. It is simply configured, but not going to impact in any way. Okay, anyway, I removed even the prefix list now. It should be now as a normal route distribution, no attachment of any attribute. For that, I need to go and check it on R5. Show IP BGP. I don't see any special attributes other than the default. No weight set, nothing. Fine. Now our targets are.
So in R5 we are not advertising anything. These are from R6, R7, R8, and R9 routes.
Correct.
So R5 learned these routes, and R5 is sending out on these next hops. If these routes are originated in this router, we should see next hop as 0.0.8.
Correct. Correct. You see, if I take you to router 9, you will see what you are talking. Show IP BGP, you can see them here. 99 all having next hop 0000. This is origin. This is not origin code. This is origin. Local origin is preferred over the learned routes. That attribute is 3. Attribute 3. First attribute is weight, second attribute is AS path, the third attribute is origin. Local origin is preferred over learned one, meaning if the same network is given by someone else, that someone else route will be available in the BGP table, but it won't be seen in the routing table because the own networks local origin is preferred over the learned one. Right. So shall we continue with our weight? Now, if I R9, okay.
So when we see something like this, BGP table, so like for 6, 7, 8 networks, it has a different next hop, blah blah blah. So I should automatically assume that these are the earned by R9.
Yeah, these are the source, these are the peers, these are the neighbors who have given me the update about 6.6.00 7700
Meaning for R9 to go to this 6 network,
There are three paths.
approximately 3 next.
Yeah. There are three paths, one via router 1, another via 2, and another via 3. The chosen one is via router 1.
Got it.
Right. Now, when I trace route from router 8, trace route 9.9.9.4.1 with a source of loopback 1, you can see it goes via router 2. The reason is router 5's next stop. Router 5's next stop to reach. Router 5's next stop to reach 941 is router 2. Now, what if I do not like this? What if the service provider don't like this, or what if I don't like this? The reason is I asked, I'm in router 8. I asked my service provider to provide a security VPN. This is IPsec path. But hmm,
Okay, from next stop was router 5, then to router 2, and then to router 9. Okay, done.
yeah, so my request to the service provider is put me on an IPsec tunnel. Assume that there is an IPsec tunnel via router 5 to router 3. I got an IPsec tunnel in this path. But right now the path is going this way. It's not a secure tunnel. It is not a secured path. I subscribe for a secured path. One is ISP can match my traffics and put me in IPsec path, or router 5 can do like this. If any traffic that wants to go to 999 or any destination, let's say anything that comes to router 5 from anywhere, going to anywhere, should be sent via this path. And if this breaks, only then as a backup it can go via this path. Right? So we are going to now do those things by simply configuring wait. Very simple. I need to just go to router 5 and say you are receiving routes from two sources, but weightage to router 3 is given routes or more. As of now, come on, router 5, J, router 5. Right now you are learning from both 3 and 2, but I want to give more weightage to 3. Even though the hop counts are same, origin code is same, when I increase the weight comes before a hop AS path, before origin. So when I set weight higher, all the routes that I learned from router 3 will be the preferred routes over the other routes. Currently, show IP route BGP, I got next stop as 22222 for all the 9 networks. But when I put this command router BGP 45 neighbor, what is router 3's address? This is router 3's address 35.35.35.3. neighbor this, weight, give more weight. 0 is default, and I'm going to say 10. So not only 99 network, all the networks. In our case, there is only one network, 999, sorry, 9.9 coming from router 3 to router 5. But in the real world, when you say a neighbor and weight, all the networks that is preferred, that is given by that neighbor will be preferred. So that neighbor is going to be preferred for all those networks he advertises. Because the other neighbor who advertises the same thing has got only the weightage 0. Higher is preferred. So now if you type and see show IP BGP first, you see the weight is not getting added yet because I need to refresh. Clear IP. Whenever you do some changes to the attribute, you can wait long and then you will see the changes, but if you want immediate change, you need to refresh like this. Now you see, earlier the greater than symbol was here, now it shifted up one step. And if you type this command show IP BGP, sorry, show IP route BGP, you will see now all having an X-top 3. And the customer expectation is now met. You see now if I trace route, it goes via router 3. Only when you send via router 3, you will have a encrypted path.
Okay, one question. How do we decide on which router that we should, use these attributes to manipulate the path? So,
You see,
9 dot network is getting the R5 first.
R3 first.
Oh, sorry. Not from the other.
The updates are coming from top to down.
Top to top.
And packet is going from down to top.
Sorry, can you say
The ping packet is going from down to top using the route, which was given from top to down.
So why not we are using the weight on R3 instead of R5? Because when we trace out the first hop is R5, right? Is that the reason? Or did I confuse you?
No, you did not confuse me. I'm just trying to think, and give you a better answer. You did not confuse me. What you said is correct. But the decision has to be made on router 5. Router 5 only I've got two options, to go via router 2 or to go via router 3. So it is there that change need to be done, not anywhere else.
Okay. Router 3 has got only one link, so it has no other option than send it on the way.
So router 3 will decide only when packet arrives on router 3. That cannot change the decision of router 5. So you need to go to router 5. Router 5 need to take the decision to go via 3.
Because router 5 has got more than one path to reach the destination.
Yeah. It has got an option to go via 2, go via 3. It even can go via 4. I don't know why I'm not seeing 4. Let us troubleshoot that. Show IP BGP. I'm not learning anything from 4.
Okay, so we use these attributes for the prefixes that the router is learning from destination. Right?
You're right. Mm. Router 4 is not learning it. Sorry, router 4 is not giving to router 5 because router 4 is not having neighbor with router 5. No, sorry, I have to check it in router 5. I'm checking now. 5. Show run section router BGP. Next up self is also given. Show run, not show run, show IPBGP. Okay, 9 network is learned from both router 1 as well as router 5. But because router 4 is seeing router 5's route is better. Router 5 route is better because in the previous lab we have set this. Wait, I'm going to remove this. Router BGP 10, so 45. Let me remove that wait statement on router 4. This is the reason why router 4 and 5, sorry, router 5 was not learning route from 4. Now, previous class to achieve something, we did that. Now I removed. Now, if you go to router 5 again, you'll find 3 routes in BGP table. You see, you've got 3 routes. To reach 9 network, there are 3 routes, but right now it is going via router 3 because we gave high weightage here. So this is how we set weight globally. Means this is not for particular prefix. We set weight globally by putting this command. So every network that comes from network advertisement that was learned from router 3 will be given weightage of 10. What is next? What if I want to achieve the same thing on R4? Even R4 should prefer to go via router 3. What is the option? Right now, if you go to R7 and trace route, it will not go via R5. See, I expect answer from you for this scenario. When I trace route 9941 source loopback 1, it goes via router 1, not via 5 and 3. See, only if it goes via 5, listen, only when it goes to 5, it can take this IPsec path. But according to the BGP, there R1 is the best next hop. So it goes this way. What is an option? What is an option that any traffic comes to router 4 or router 5 that wants to go to destination 99 should be forwarded this way via router 3.
Basically, I think on R4 for those neighbor 9. Okay, so the neighbor R5, we have to add a weight,
Or
or we
see,
can do, or also we can do R4 which is going via R1, make AS path dependent, load AS paths.
or
So we can choose. I'm not sure.
okay. You see, I told every router Not only 5, not only 4. If you have even more routers in this autonomous system 5, all should prefer to go via router 3. So in that case, you no need to play with weights. Even I can remove weight from router 5 and switch to local preference. Local preference is the best option. Do you agree?
Not sure.
Okay, let me show you. Router BGP 45, and then I'll put no and remove the weight. When you remove the weight, clear IP BGP star soft, and then type show IP root, show IP BGP. Now it is back to router 2. Yeah, but what is our discussion is, if packet comes from 7 also it should go this way. If packet comes from 8 also it should go this way. For that, both 4 and 5 should know, that I need to exit this way. For which I need to set local preference like this. See, there are two ways in doing it. One is set local preference for this router, let's say 200, so that router 7 will send like this. But 5 is already going this way. Is that right? For that, you can include weight so that after coming here, 5 will say this way. You understood?
Okay.
So this is one easy solution. I'll also tell you another solution. But easy solution is, let me go and do it again. On router 5, I'm going to say router BGP 45, BGP default local preference 200. And then let us clear IP BGP star soft, show IP BGP. Now we will see the impact only on router 4. Let me trace route on router 7 to show you the impact on router 4. When I trace route earlier, it was going via router 1, but now it is going via 5 and 2. It is going via 5, we are happy, but going via 2, we are not happy. So for that, what we can do is we can set weight again, like before.
BGP default local preferences.
For all the routes,
Oh,
router 5 is the exit in this autonomous system. When I say that in router 5, even router 4 will know it. I'll show you in router 4.
what if there is a similar configuration on router 1?
Then it is a tie. No, router 1 is not in this autonomous system. It doesn't matter. If router 1 is in this autonomous system 45,
Okay,
then only it will go to the next attribute. Now, you see, show IP BGP. You can see the 200 that I set on router 5 reflecting here. That is why router 4 says I'll go via router 5. Okay, what is next is, next is, now we are going to,
and what else we have to do on router 5?
yeah, to take it to router 3. For that, I need to go to router 5 and say, router 5, you have two routes, one from router 3 and router 2, but we prefer router 3. How to do that? Router BGP 45, we did already this one. Neighbors so and so, weight is 10. Now clear IPBGP star soft, and I'll go back to router 7 and trace the route. It should go via 3 now. Look at this. So we can use this attribute like local preference and weight mixed as a solution. There is also another solution to this. Let's see that. On R5, I'm going to remove the weight. Okay. And I'm also going to remove the local preference that we enabled globally. Okay. I did it.
So this local preference 200 BGP default local preference 200. So whichever router is connected to R5 and has BGP,
They all will send here.
all will send to R5.
Mm. This is not our preferred path, right? So when I remove that, it starts going via router 1. Now, how can we do this in another way by just simply using local preference? In a router 5, we made things more complicated by adding both local preference and weight. To make it simple, I can say like this. IP, you can use access list or prefix list. Because you are asking for prefix list, I'm doing this with prefix list. IP prefix list 10. That's just a name I'm giving, 10. It can be even an alphabet number, a word like policy 1, right? And then I need to say permit those prefixes 9.9.1.1 /32, 9.9.2.2/32. See, if it is summarized, you will only mention the summary. In the real world, we have summarized one. You no need to mention these 3 lines. And now what I...
3.1, right? 2.1, 3.1.
Yeah. 3.1 and 2.1. So I need to remove those. Do show run section IP prefix list. Now you can see prefix list 5 has got this, 20 has got the sequence number under, automatically it will give. Right now, I'm going to attach this to a route map. IP route map, not IP route map, route map, policy 1, match IP address, prefix list, lowercase, policy 1 I give there. You see here this name, same name I need to call.
Yeah, same name.
All right, policy 1. If this match happens, set local preference 200. Okay. Now I need to call this router BGP 45 neighbor router 3's address, which is 35.35.35.35.3 route map. Please focus. Route map, and I call this route map, and I need to say in, means when the update comes in from this guy. When the route update comes in from this guy, you need to attach 200 as a local preference. Now for all the rest of the traffic, you need to create simply one route map with policy 20, sequence number 20 and leave it. Now let me show you first clear IP BGP star soft. And then I'll do one to before that show IP, show route map. In the route map, you see policy 1. The sequence 10 we did not give, it comes automatically. We attach the prefix list pol 1 and we are setting 200. If if it is not matching with prefix list, it will come to sequence number 20 and it will be simply permitted without any changes. Now,
Okay, one question, Jay. So when we are using route maps, is it mandatory that we should use this blank route map?
you must. That is like a permit any statement in access list. In access list. In access list, whatever doesn't match will be denied. No implicit deny will be there. Likewise. In route map also implicit deny will be there. All right, now if I go to router 5 and check show IP BGP, you will see only for 999 the local preference is 200 given. You see that? So you go trace route now. You go trace route now. Wait a minute. I'm seeing something abnormal here. 994. Okay, I did not add this in the prefix list.
Yes, yes.
So what happens is when I trace route 41, it will go via router 2. No, for that it goes via router 1, the default path. And when I trace route 4.2, sorry, 3.1, it goes via 5 and 3. 5 and 3. This is how we can use the route map and the prefix list to manipulate our path selection. Right? We'll start.